Hey, Steve Trimble. In this connected construction tip, we're going to show you how to do a volume analysis for a sloped parking garage structure. So here you can see it's pre-pour. We're going to actually align this to a known elevation from an RTS right here, just by manually doing that through the scan data because we were unable to do it in the field. We just didn't have control then, but scan data is nice. We can always come back later and do this. So we'll make this a little bit bigger. So initially, we did do it with FieldLink on the tablet with a floor analysis, and we'll show you what that answer looks like. If I was just looking at volume, I can actually turn this on and then change that. Let's make this 6 inches. So with that, you can see higher in red, lower in blue. It's great for volume analysis, but obviously because this is sloped, it's going to be a little bit difficult to look at that and actually see what the slope is. So if I did a floor analysis, which we've also completed, hence the points there, I can do a reference point to a known, or essentially to an elevation, which we did here, elevation at 808.99. Which is on the slab, but because the slab is sloping everywhere, it will give us a volume of roughly how much concrete is needed. But to do the scan to the slope analysis volume, we're going to send this over to TBC. So to do that, I will export to BIM a TDX here, and we'll keep it there. I do want to refine this. Maybe I actually should do that first. So we did refine it real quick. And then we're going to open up TBC. So with TBC open, project created, we just dragged and dropped the TDX in. That'll bring the TZFs over. And those will generate. And we have it on control because we did that in FieldLink. We'll also bring over some of these models just so we can see them as well too. Dragging and dropping them. And they can help tell us where we want to do this analysis for the upcoming pour. So here we can see we have both models in, a DXF and a ETM of the desired floor height, and then we have the DXF to give us this line work too. So we're going to do some classification. Let me go into point cloud classify. And this will allow us to extract out just the ground very quickly. And we'll do all classes and classify and refine. So it should just give us the ground data there. So those have been created. We can turn off, actually, we just close out most of these because we really need them. The filter, scan data, we'll just turn on the ground. So just found all the ground there. We'll turn off the layers of the other one. And what we can do is sample by region here to make this a little bit smaller to work with too, because there'll be a couple million points that we can bring down in area. So this will make it a smaller point cloud. So we have the sampled refined area. We'll create a region. Close this one first. Create a region. We'll call this pour area. And then add to region. We will create another region. Actually, let's do this. And then add to region. We'll call this steps. Now we'll keep that closed. All right, we're okay with that. We have a little pour area. and the needed area. So then we will go to surfaces and create a surface. New surface, we'll call it pore area. Surface classification, keep it unclassified, selected, and click OK. And that should create us a ground contour of those points or surface area. Then we can do a surface to surface inspection with the desired surface. So both of these have slopes in them, like we were discussing. We'll see that here. So surfaces, there's our pore area. If we actually, so there's our surface. If we look at it in a 3D view, you can see that, the surface on top of it. And then we should be able to see the surfaces that we brought in too. By turning them on. So you can see our surface below the design surface by about 5 inches, which should be about the thickness of that slab. So we have two surfaces. Actually keep this one turned on. We can select the two and do a pore area surface to surface inspection. So we can go to earthworks report, surface to surface. We got pore area. We will actually not use that TRB. We're going to delete that and bring in our, if we look at it, news TTM. So it's recognized as a surface. There we go. So now we have initial, which will be pore area. Final will be new slab. No boundaries, and we just want volume. So that's going to tell us versus the existing of the scan data and the imported TTM, what is the total volume distance. So in FieldLink to a flat surface, not 1 point, we're able to calculate 224 cubic yards. But because the finished concrete is sloped and we weren't accounting for that, so it could be over, it could be lower, and we'll see what the actual needed amount of concrete is for that pour. All right, so with that, we have our creative report of that 12,000, 13,000 square foot area. We need 240 yards of concrete, so 24 trucks, 0.9. Would want to actually probably double check. We're right on the edge, but if I could compare and really look at the amount or the scan data that we're going in, make sure that we aren't including or excluding anything. It did look like it actually was pretty great and pretty close. You can see that is what it's going to be including and doing the analysis too. So thank you. Please reach out to your nearest building point representative if you have any questions.